Hello everybody and welcome back to another video by Funland Tutorials. In today's video we are going to be covering a different topic, a new topic, which will be essentially the concept of dynamic game. So this topic falls under game theory. Dynamic games are also called sequential games. Now we'll understand why they are called sequential games. Of course, from the name we can understand that there's some sort of sequence involved in the game. Let us first understand why it's called a dynamic game, and through that we'll understand why this concept, that is the concept of dynamic or sequential games, use a method of representation by which we call a game tree. So essentially we represent a game in this form. So if the game is in dynamic or sequential form, then we represent it through something called the game tree. Let us first understand what the game tree is, and that will essentially explain us the definition or the principle of the dynamic game or sequential game. In order to understand what a game tree is, let us first assume certain situations. So suppose there has to be some players when we are playing a game. So let us assume that there are two players, right? So we consider player, let's say there's player 1 and player 2. So these are the two players, and by sequential what we essentially mean is player 1 decides on a particular action, and then following the player 1's action, so player 2 observes player 1's action and then player 2 makes a second decision. That is why it's a sequence. So the actions are taken sequentially, one after the other, and not simultaneously. Essentially the opposite of sequential game is simultaneous game, which we will be studying later. So let me just write the opposite of sequential. So I'll just write opposite is a simultaneous game. So we have something called a simultaneous game as well, which essentially not contradicts, but it's essentially the reverse of sequential game. Here, for the time being, we will be concentrating on sequential game. So that is what we will be studying in this video. Now let us start with a particular example, then it will become easier to understand. Suppose we start with the player 1. So the player 1 first gets to decide what will happen, right? So it's player 1's, the first turn belongs to player 1. And the player 1 can choose between two options. So the player 1 can either choose between an option A, suppose, and the player 1 can also choose option B. So the player 1 is given two options. He or she can either choose option A or option B. You can think of it in this way. The player 1 can essentially decide whether he or she will choose the left path or the right path. And based on what player 1 chooses, player 2 can then choose what he or she will do. So in the first turn we have player 1's decision being made. So this is the first turn. In the first turn it's player 1's decision being made, and in the second turn we then ask second player, so what do you want to do? Now that you have seen what player 1 has done, what do you want to do? So essentially when we draw player 2 in this node, this is called the node. So one thing that we learn is these positions, these circles, these are called nodes, and these strings, so these strings are called the branches of a tree. Essentially as we keep spreading and developing the game, this starts branching out. So at one point of time we'll have something like this, and then it will branch out again, and then this may branch out again, and essentially we form something like a delta or a distributary system like the river. This kind of looks like a tree, so we call this a game tree. This method of representation is called a game tree. Now when we look at a game tree, these nodes, these are called the nodes, the point where the strings branch out. So if you think of the system that we just took for an example, so if you think of something like this, this will be a very difficult and complicated situation. Suppose you consider something like this. If I want to change the color of this ink, let me just change the color, that will make it easier. These points, so the points where essentially the strings branch out, these are called the nodes. So let me just write the word down for terminology purposes. These are called nodes, right? So these are the nodes of the game, and we also have the branches. The branches are essentially the strings that are being spread out from each node, right? So that is the terminology. Now let me just remove them so that we can get back to the game that we were originally considering. So suppose this is the first turn, so player 1 can choose either A or B, and after player 1 chooses A or B, essentially, player 1 can see whether player 1 has chosen, player 2 can see whether player 1 has chosen A or B. So if I consider player 2 to be here, it means player 2 has observed that look, player 1 has chosen A, so I am in this situation. If I think player 2 is in this situation, it means player 2 knows, that is, he or she has observed, look, player 1 has chosen B, hence I am in this situation. So the player 2 can essentially observe what player 1 has done, and that is why player 2 can know whether he or she is in this position or whether he or she is in this position. Given this situation, player 2 can now choose his or her own strategy, right? So suppose in both cases, suppose the player 2 has option A, small a and small b. So even if player 1 chooses capital A, player 2 will still have the two options small a and small b, and even if player 1 chooses capital B, player 2 will still have option A and B. You can generalize it to P and Q as well, so we can actually generalize it to say P and Q. Now generalizing it means essentially based on what I had previously written. If I had written AB, it essentially means whether player 1 chooses capital A or capital B, player 2's strategy set does not change. So if player 1 decides, no, I'll go left or I'll go right, player 2 will have the same options. Suppose player 1 wants to go at a restaurant, suppose player 1 wants to go at a football field, either it wants to go for a football match or it wants to go for a movie night. Player 2 has two options, either it can drive or it can be the passenger, right? So whatever be player 1's decision, whether player 1 wants to go for a football match or for a movie night, player 2 can either be a driver or a passenger. There is no change in the strategy set, that is, there is no change in the options given to player 2. That is one possibility. One other possibility is that based on what player 1 chooses, player 2 can actually change his or her own strategy itself. So player 1 can say, wait, I either want to spend my night at home. So suppose I want to spend my night at home, or I want to go somewhere. So this is go somewhere and this is suppose home. So if the player 1 decides that I will stay home, player 2 can either go somewhere or stay at home. And if player 1 decides to go somewhere, player 2 can then decide whether I want to be the driver or whether I want to be the passenger, right? So in this case, in the latter case that I said, based on player 1's choices, player 2's strategy set itself changes. So if player 1 decides capital A, player 2 has two options, but if player 1 chooses capital B, player 2's option set itself changes. That is one possibility. Here we are choosing the generalized version. So we are, suppose for the sake of generalization, we are saying that player 2's option set itself changes. So player 1 if plays capital A, player 2 can play small a and small b, and if player 1 chooses capital B, then player 2 choose small q or small p, right? That is small q and small p. Now suppose we arrive at a situation where player 1 plays capital N and player 2 plays small a. If that happens, then let us suppose that the payoffs are 6,3. Now what does this payoff essentially mean? A payoff is essentially what you get after a particular game unfolds. So suppose player 1 had said, I want to go somewhere, and player 2 said, okay, fine, I'll drive the car and we'll go there together. This means this payoff 6,3 can be interpreted as follows. Player 1, so since player 1 is the first player, we always take the first number to be the player 1 and the second number to be the player 2. So this can be interpreted as follows. 6 can be thought of as the utility derived by player 1 and 3 can be thought of as the utility derived by player 2. This bracket, this number set is called the payoff. It essentially means what is the benefit that player 1 and player 2 receives after this game unfolds in this particular path. That is, player 1 chooses capital N, player 2 chooses capital, player 1 chooses capital N, player 2 chooses small a. This can be one payoff, but if the game unfolds in this way, so game unfolds in this way and then player 2 chooses small b, that could also be a possibility. In that case, suppose the payoff is 2, 1, which means if player 1 chooses capital A and player 2 chooses small b, then player 1 will get a payoff of 2 and player 2 will get a payoff of 1. So, this number essentially gives you the payoff, what each player gets from a particular development of the game. Similarly, suppose we have payoffs 8, 3. If this particular path unfolds, and suppose we have this payoff 2, 5 if this particular game develops in this way. That is, if player 1 chooses capital B and player 2 chooses small q, then player 1 will get 2 utility. It can also actually be profit, it can be revenue, essentially what the players get, and player 2 will get utility or whatever he or she wants of 5 units. Suppose this is the situation. Now, how do we solve these games? We solve these games by something called a backward induction. So, what is this backward induction? Backward induction, as the name suggests, we start the game backwards. So, let me just explain once. Suppose, let me just change the color, that will again make things easier to understand. So, if this, let me just change the color. Let me start off from this set. So, this is the last place where the game ends. We will start off from this place, that is, we will go in the backward direction. So, suppose player 1 had chosen A, that means player 2 is in this situation. Player 2 now sees, given that player 1 has already played capital A, I can see that, as I mentioned before, player 2 knows that player 1 has played capital A. Now, I myself as player 2 know that if I play small a, I will get, that is player 2 will get 3. And if I play small b, that is if player 2 plays small b, the player 2 will get 1. This is from player 2's perspective, because we are at a node where player 2 is the player. That is, the player 2 is the decision maker. The player 2 sees that if given this path has been chosen, if player 2 plays small a, he or she gets 3, and if player 2 chooses small b, he or she gets 1. Given that this is a positive utility or a positive benefit, essentially, player 2 will always prefer 3 over 1 because 3 is greater than 1. So, essentially, if this path is chosen, that is, if player 1 actually ends up choosing capital A, player 2 will always choose capital small a, because 3 is greater than 1, which means this is not a possibility. So, this always happens, which means if player 1 chooses capital A, this entire set boils down to 6, 3. Because the player 2 will obviously, given that of course the player 2 is rational, the player 2 will always choose small a, and the game will boil down to 6, 3. Similarly, if we look at this part, the player 2 will see that if given that player 1 has played capital B, if player 2 chooses small p, he or she will get a benefit of 3, which is the second number. And if the player 2 chooses small q, he or she will get 5, which is the payoff of the second player. In this case, the player 2 will decide that I will choose q and not p because 5 is greater than 3. So, this will boil down to 2, 5, right. Now, what happens is, based on, we have solved this part based on player 2's perspective. So, player 2 knows that if player 1 chooses so and so, I will choose this, that means my payoff will be this. So, I know what to do. Player 2 knows what to do. Given player 1's decision, player 2 knows what to do. Now, we look at player 1's perspective. So, player 1 knows that player 2 knows, essentially there is something called perfect information. Everybody knows that everybody knows everything. So, player 1 knows that if I play capital A, player 2 will end up doing something which will give me a payoff of 6 as player 1. Since we are looking at the first player's objective, player 1 knows that if I play capital A, player 2 will do something. I don't know what, but player 2 will do something given that he is rational, and I know that he is rational. Player 2 will do something that will give me a payoff of 6. Player 1, 6 will be the payoff of player 1. And if I play B, my payoff will be 2, because I know player 2 is rational and player 2 will do something so that my final result will be a payoff of 2. Now that I know that at capital A I get 6 and with capital B I get 2, of course I will choose capital A because 6 is greater than 2, which means again this portion is invalidated because I will never choose a lower number. I will always want to be as good as possible. which means player 1 will choose capital A because it gives him or her a higher utility, and player 2 accordingly, as we had done the reverse calculation, will choose A. That means the game will unfold in this path. This principle is called the principle of backward induction, and essentially we are moving in the reverse direction. We are starting off from the last stage and we are climbing our way up into the top of the tree. This structure is called the game tree. The way in which we solve the game is called backward induction, and this type of game is called a dynamic game or a sequential game. Because this is a dynamic game, essentially the players take their decisions one after the other. Hence there is a sort of an intertemporal concept being made, and that is why it's called a dynamic game. And since the decisions are being made one after the other, it's called a sequential game.